All right, so today what we're going to be doing is we're going to be talking about empirical rule and z-scores. So those are the um, last two topics, major topics that it's going to be in your midterm exam. All right, so my goal has been to just cover um, all the topics so you'll be prepared for your midterm exam. So, so let's go ahead and dive right into it. All right, so um, the empirical rule. So what is that? So it says here, it turns out all normal distributions have the characteristics described on this page. The diagrams on this page are normal curves with the mean of mu, it's a Greek letter, and a standard deviation of sigma. Notice the mean mu is at the center. Adding one standard deviation to the mean would be mu plus sigma. Subtracting one standard deviation from the mean is mu minus sigma. The area under the curve represents likelihoods or probabilities. Okay, so at first, this is a little bit kind of confusing, but hopefully by the end of this lecture, you'll be able to understand this much, much more. Okay, so um, so the middle is the mean, okay? The average. So it's represented by it looks like a letter U, but it's mu, it's a Greek letter. And then one standard above, okay, it looks like a slanted six or like a zero. One standard above and one standard below, okay, is 68% of your data. All right. And then two standards above and two standards below is 95% of your data. And then three standards above and three standards below is 99.7% of your data. Okay. So um, we're going to analyze this for a little bit and then answer some questions. So let's look at the next slide here. Okay. All right. So right now, what I want you to do is to just look over this number distribution curve. Okay. And try to deduce or figure out, okay, what these questions are asking and make your educated guess. And then we'll go back and make sure we get these correct. So look at these problems and see if you can figure them out, and then we'll go over them. And the goal is to get acclimated with this distribution curve. Okay, so before we answer these questions, let's go back to the previous slide here. Okay. So as I mentioned, this is called the empirical rule. Okay. And these approximations, okay, within the standard deviation of the mean, okay, they have different terms of describing them. Okay. So um let me just list some of them. So sometimes they describe this normal distribution curve, right? These are normal distribution. That's what they call these curves. Okay. Um, Sometimes they refer to them as area, to finding the area underneath the curve. Sometimes they refer to them as proportion. Okay, finding the proportion, the percentile, or probability. Okay. So all these terms, okay, they mean the same thing. All right. So, but they're interchange them. They'll say, okay, find the area underneath this curve or within these standard deviation. find the proportion or the percentile or the probability. Okay, so just be aware of that. All right, so sometimes I'll say likelihoods as well. Okay, so there are different types of distribution curves, and we're going to learn about those. But this one we're focusing on is called the normal distribution curve. Okay, and Um, there's a couple ways of analyzing these. There's actually many ways, but the two things we're going to be focusing on first is the empirical rule, which is the 68, 95, 99.7 rule. And the other rule is going to be the z-scores. Okay. So let's go to our next slide here. So um, it says, due to symmetry, the areas can be further split up as shown in the diagram below. The first question it's asking us is, what is the area under the curve to the left of mu minus sigma? Okay. So you notice that as we look at this curve, normal distribution curve, basically it's a reflection of each other, right? 34% is on the left, 34% is on the right, 13.5% is on the left, 13.5% is on the right, so on and so forth. Okay, so they're just reflecting each other's information. Okay. So what does it mean when it says find the area under the curve to the left of mu minus sigma? Okay. So first we want to find where mu minus sigma is, which is right here, right? This is mu minus sigma. Okay. And what we want to do is we want to um, add up the areas that are to the left of mu minus sigma. Okay. So again, it's saying to the left. So that means if we were to shade this, we want everything to the left of mu minus sigma. So that means we would need to add up all the areas to the left of here. Okay. So that would be these three percentages. Okay. When we add those up, all right, so I'll put that on the right here. So 0.15 plus 2.35 plus 13.5. That's going to give us 16%. Okay. So we would write 16% here. So that means the area or the proportion to the left of mu minus sigma is 16%. Okay. All right. Let's go to the next question. Okay. Now we want to find the area under the curve to the right of mu plus 2 sigma. So here's mu plus 2 sigma. Okay. So again, if we were to shade the area to the right of mu plus 2 sigma, it would be all of this here. Okay. So what does that mean? That means we would need to add the two areas that compose mu plus 2 sigma. Okay. That is to the right of it. So we would add these guys here. Okay. So that would be 2.35 plus 0.15. Okay. So when we do that, we get 2.5%. Okay, now let's go to the next question. If all the percentages in the diagram are added together, they equal, which most of you got, would be 100%. Okay, so if you add up everything to, add up all the percentages here, they would add up to 100%. Okay, and then the last question here says, the area under the curve to the left of mu plus 2 sigma. So again, we looked at the area to the curve to the right, but now it wants us to add the area or find out the area to the left of mu plus 2 sigma. So again, here's mu plus 2 sigma. So it wants everything to the left of that. So this, all of this area here to the left. Okay. So that means then we would add up all the area to the left. Okay. So I know that since all of this is 100%, half of this has to be 50%, correct? Half of that's 50% because the other half is 50. So I don't have to keep adding all this right here because it's half of that's already 50. So I can do 50 plus the 34, okay, plus the 13.5, okay? Because again, all of this added together, that's half of the graph. That's 50%, okay? All right. So when we add those, we would get 97.5%. Okay. So another way to figure this out, we already figured out to the right of it was 2.5%. Okay. We already figured out it was 2.5%. So what we can do is we can just do 100 minus 2.5, and that will also give us the left of that for mu plus 2 sigma. Okay. So there's a lot of ways of getting the same answer. Okay. Okay. So here it talks about the average temperature of Indianapolis in September. Okay. It says use a mean of value of 66.7 degrees Fahrenheit and standard deviation of 9.41 degrees Fahrenheit to label mu, mu plus sigma, etc. above. Okay, so when we have a normal distribution curve like this, okay, the first thing we need to do is fill out the information on the bottom. Okay, and we always want to start in the middle, right? We always want to start in the middle. So I might need to, yeah, yeah. So it tells us, right? So in the middle, it's going to be your mean. Okay, so that's represented by mu. Okay, and then to the right of that is going to be mu plus sigma. Okay, and then to the left of that will be mu plus, I'm sorry, mu minus sigma. Okay, all right. Then you just keep deducting two standards, three standards from the left, and then same thing to the right. You add one standard, two standard, three standards to the right. So here we have 66.70 degrees Fahrenheit. So I'm going to put that right here in the middle. I'm writing a little bit small and lighter here so I can fit my information. Again, if you can't see that, you can um, zoom in on your end. Okay, so we have 66.70. We always start in the middle. And then it wants us, there's a standard deviation of 9.41 degrees. So that means we need to add 9.41 to the right. Okay, so when we add 9.41 to the right, that's going to give us 76.11 for one standard above. Okay, and then if when it says mu plus 2 sigma, that's going to be two standards above. So we just add another 9.41. Okay, so that gives us 85.52, and then another sigma, so that'll be 3 sigma. We just add another 9.41 to the right. So that gives us 94.93. Okay. All right. Now we're going to do exactly the same thing, but just the opposite, going the other direction. Okay, so now it's saying mu minus sigma, so we're going to subtract 9.41. Yeah. Okay, so when we subtract 9.41, we're going to get 57.29. All right, then this will be mu minus 2 sigma, and then mu minus 3 sigma. Okay, so again, we keep doing this, subtract 9.41, Subtract 9.41. Okay. All right, so we'll get 47.88 and then 38.47. Okay. Now, before I start answering the questions, what I like to do is label my 68, 95, and 99.7. Okay. So what do I mean by that? So let's use this color here. Okay. So remember, it tells us that within plus or minus sigma is 68% of your data. Within plus 2 minus 2 sigma is 95% of your data. And plus 3 and minus 3 sigma is 99.7% of your data. So, um, so that means um, from here to here, okay, is 68% of your data. From here to here, okay, is 95%. And then from the last one all the way here, okay, is 99.7%. Okay, so a lot of the questions are going to probably derive from these three areas. So I just label them automatically. Okay. So for example, it says approximately 95% of the days of September fall between what two temperatures? Well, I already wrote down 95%, right? Here's 95%. And what two temperatures lie between 95%? Well, that's going to be what? 47.88 and 85.52. So I just write down between 47.88 and 85.52. Okay. All right, let's go to the next question. It says, how likely is it that a September day will be warmer than approximately 95 degrees Fahrenheit? Okay, so um, okay, so if we go back to our previous slide, right? So first of all, let's look at 95 degrees Fahrenheit. The closest we have for 95 degrees Fahrenheit is 94.93. Again, these are all approximations, right? So that's the closest we got. So it's asking warmer, right? Warmer means hotter. So we don't want to go to the left because that's going to make it cooler. We want to go to the right. We'll make it warmer. So we want this area right here. This is what we want. Okay, what's this area right here? Well, if we go to our previous slide, it tells us it's 0.15%. Okay, so how likely is it that a September day will be warmer than 95% degrees Fahrenheit? Well, it's very unlikely. Okay, it's very unlikely. It's less than 0.15%. Okay, let's look at the next question now. Based on these values, how many days in September could we expect the temperature to be less than 57 degrees Fahrenheit? Okay, so first of all, we need to figure out how many days are there in September, and out of those days, um, how many will be less than 57 degrees Fahrenheit? Okay, so first of all, we need to figure out how many days are there in September, right? So if you look in your calendar, there are 30 days in September. All right, so 30 days. All right. And what we want is we want what's the, probability or the likelihood of it going to be less than 57 degrees Fahrenheit. So less than 57 degrees Fahrenheit. Well, 57 degrees Fahrenheit, the closest that we have is 57.29. Okay. That's the closest that we have. So we want less than, so that means we want this area below it. Okay. And if you think about it, we already calculated that area, right, on our previous slide, right? It's this area right here. Okay. So that would have been the 16%. So you would add, the 0.15, 2.35, and 13.5%. That gives you 16%. So we already calculated that on our previous slide here. So, so again, that was 0.15 plus 2.35 plus 13.5. Okay. So that gave us the 16%. So this area here, okay, is 16%. So all we have to do is take our 30 days and then multiply that by the 16%. Okay. And so when we do that, we get about 4.8 days. But it wants us to round to the nearest whole days, so that's going to be 5 days. Okay, so that's our answer there. Okay, so here, our next slide, it says a popcorn company builds a machine filled with 1 kilogram bags of popcorn. They test the first 100 bags filled and find that the bags have an average weight of 1,040 grams with a standard deviation of 25 grams. Fill out the normal distribution curve for this situation. So pause here. Okay, so again, the first thing you want to do when you fill out this distribution curve, you want to start in the middle. All right, so that's going to be the average. So the average is 1,040 grams. So we'll have 1,040 grams here. All right. And then it's the standard deviation of 25 grams. So that means we're going to add 25 grams every time to the right. So we'll get 1,065, 1,090, and 1115. Okay. And then to the left, we're just going to subtract 25 each time. So we have 1015, 990, and I believe that's 965. Okay. All right. All right, so make sure you fill this out correctly because all your information is going to be based off of this. So if you make a simple calculation wrong error, then your answers are not going to be correct. Okay, so I can double, triple check that. All right, and then as I mentioned, I just like to label this. So 68, 95, 99.7. Okay, so we got 68% within here, 95% within here. And then 99.7 within here. Okay. It says the middle 95% of people would receive bags between what weights? So here's 95%. Okay, so that's going to be 990 and 1090. All right, which most of you guys got. So let's write that down here. So 990 and 1090. Okay. All right. Number three, what proportion of customers will receive bags weighing at least 990 grams? All right, so here's 990 again. All right, we want at least, so that means You think about it, so you have to be at least 18 years old, to work at this place, or you have to be at least 21 years old to enter this place, or something like that. All right. So, so it has to be the number and then above, right? The number included and then above. So in this case, we would um, add everything to the right of that. So, so everything here to the right. All right. So that would be, go back to our previous slide. That would be the 13.5 all the way to the right. Okay. Oops. Okay. So, um, everything all the way to the right here. Okay, so we have 13.5 plus the 34%, and then half of that is 50%. Okay. So that will give us a total of 97.5. Okay, so again, 13.5 is here, right? 34 is here. And then all of this to the right of that is 50%, right? Because half of the graph is 50%. Okay, so that's how we got our answer here. And then the last one, estimate what percentage of customers who receive bags weighing less than 1 kilogram. So 1 kilogram is 1,000 grams. Okay. So the closest that we have is I don't know why it keeps doing that, is 1015, right? Because we picked 99 is too low. So 1015 is our closest one. So part of the 13.5% and everything, everything here, right? So all these three areas here. So that will be the 0.15 plus 2.35, right? Because this is 0.15, this is 2.35, okay? And then this is 13.5, and then and part of 13.5. Okay. So that's going to give us about, so this little squiggly means about um, approximation less than 16%. Okay. So we talked about the empirical rule, and then that's an approximation. As you notice, it had its limitations, all right? So we have another type of approximation that's going to be a better approximation, and it's called the z-scores, okay? It's the same process in regards to we need to find the area underneath the curve, okay? Or the proportion, percentile, whatever you want to call it, all right? But this one is a little bit better in regards to telling us, what the area is underneath the curve, okay? So it says recall that the total area under the normal curve is 100% or 1.0. Due to symmetry, the area to the left and to the right of the mean is 50%. Okay. Says the bottom row of the graph lists z-score. So z-score of -3 represent 3 standard deviations to the left of the mean, and a z-score 2 represent 2 standard deviations to the right of the mean. Typically, z-scores range from -3.5 and 3.5, positive 3.5. A z-score is a number of standard deviations from the mean. The formula for calculating a z-score is z is equal to the value, so that's the number that's given to you, minus mean, or mu, and then divided by the standard deviation. And what I like to tell students is, make sure you put this in parentheses, okay? So that you need to calculate that first, press enter, and then divide it by the standard deviation, okay? So, um, make sure you do that, right? Because um, you'll get the wrong result if you don't. Okay, so so here is another way to, again, as I mentioned, to approximate the area underneath the curve or the probability or proportion. Okay, So let's go dive into the questions. And so we're going to be using this formula down here to answer the questions. So let's go to the questions. It says, recall the manufacturing example with an average of 1,040 grams and a standard deviation of 25 grams. Calculate the z-score for a bag that weighs 1,000 grams. Okay, so here is an example they give us. So you take z is equal to 1,000. That's the number that they give you, minus the average, which was 1,040 grams, divided by the standard deviation, which is 25. And then you get a z-score of negative 1.6. Okay? In a minute, we'll discuss what this means and how we can find that. Okay? So let's look at the next example here. It says, let's look at an example. The average adult male is approximately 70 inches in height, and we will use standard deviation of 5 inches. Okay. What is the z-score for a man who is 65 inches in height? So again, what we want to do is use the formula. Z is equal to x minus mu over sigma. All right. And again, you want to put these guys on the top in parentheses. Okay. So again, how do you do this? So first we're going to write down what's given to us. Okay. So x. So that's what's given. It says, what is the z-score for a man who is 65 inches in height? So that's where 65 is going to go where x is. So I'm going to put 65 here. Okay. And then mu is the average. The average is 70 inches, right? That's mu. So I'm going to put 70 here. And then the standard deviation is 5 inches. So I'm going to put 5 inches down here. Okay. All right. So we just put this in the calculator and we get negative 5 on top. 65 minus 70 is negative 5. And divided by 5 is going to give us negative 1. All right. So we get a z-score of negative 1, and that would be our answer there. Okay, so for number 2 is, what is the z-score for a man 77 inches in height? So again, we have z is equal to 77 minus 70 divided by 5. I'm going to put that in parentheses. So 70 minus 70 is 7. So 7 divided by 5 is going to give us 1.4. Okay. All right, let's look at the next question. It says, find the z-score for a man who is 6 foot 2 inches tall. All right, so the previous problems, it already told us what it was in inches. So this time it's saying 6 foot and 2 inches. So what we need to do is we need to convert this all into inches. So remember, 12 inches is equal to 1 foot. Okay, so 12 inches is equal to 1 foot. So all we have to do is multiply 12 times 6. Okay, so 12 times 6 is going to give us 72. Then we have the extra 2 inches, so we're going to add 2 more inches, which is going to be 74 inches. Okay, so for this problem, we just do exactly the same thing. We're going to have 74 now minus 70 divided by 5. Okay, so that's going to give us 4 over 5, which is 0.8. Okay. All right, and then the last one here, 4. Number 5 is the same thing as number 3, so I'm not going to go through that. So number 4 is, how tall is an adult who is 3 standard deviations above the mean? Okay, so how tall is an adult who is 3 standard deviations above the mean? So remember, we're starting at 70 inches, right? That's the average height. So we want to go 3 standards above. So then that means we need to use a standard deviation of 5 inches. So one standard above is 5 inches, another standard above, or 2 standards above, will be another 5 inches, and 3 standards above will be another 5 inches. So this will be 3 standards above. So when we add that, we're going to get 70 plus 5, 75, 80, and then 85. Okay, so that would be 85 inches. Okay, so now we hopefully know how to calculate the z-score. What does this mean? How do we find out what the area is? Okay, so let's go to the next slide. And it says using z-scores to find probabilities. In the previous section, we learned about the area under the curve for values 1, 2, and 3 standard deviations from the mean. We can use z-scores in the table below for values that do not fall directly on a standard deviation. The z-table below gives the proportion under the curve, normal curve to the left of the given z-score. These proportions can also be referred to as probabilities, as I already mentioned. Okay? This diagram shows the area under the curve, area of the curve for men shorter than 63 inches. Okay? All right, so when you draw your normal distribution curve, right? So again, it looks like this. Then you will label, this is for z-scores, so you will label on the bottom the z-score. So 0, 1, 2, 3, 4 to the right, and then -1, -2, -3, -4 to the left. So this one they already calculated for us, right? What's the z-score for a man that's 63 inches in height? So they figured out it was -1.4. So we would mark that down here, okay? So this is where -1.4 is, okay? Left of the 0. And then it says what? You would shade to the left, right? So the area here will always be to the left, okay? It'll be shaded to the left unless it tells you otherwise. So if it doesn't say anything, it's always to the left unless it tells you otherwise. All right. And the areas that I'm going to present to you in a second, they're all the areas to the left of that number. Okay. So we need to find out what this area is. Okay. What is this area to the left of -1.4? So what's this area? Okay. So we need to look at another table. So okay, so we need to look at a z-table to figure out what this area is representing. So I will have that here. 1 second. Okay, I know it's a little bit blurry and I apologize for that. But this is the table that I'm referring to. All right, so this is, 0.00, 0.01, 0.02, so on and so forth. Okay, so you have negative numbers here on the left side here, and as you scroll down, you'll have the positive numbers. Okay, so so we want to find -1.4. That's what we want to find. So. All right, so this is the positive z-scores. We want the negative z-scores. So let's scroll back up. And here is, and I'm going to zoom in a little bit here, -1.4. All right. And it's -1.4 what? 0, 0, 0.01, 0.02, 0.03. So that's the accuracy that it has. So we just want -1.40. All right, so that would be the first column here. So we'll get this answer here, 0.0808. Okay, so what does that mean? That means, so let me go back to here. Okay, so I'm going to say this. So you can have two answers here. So you can write it as a decimal form, or you can write it as a percent. Okay, so decimal form, okay, it says it's 0.0808. All right. In the max number you can get in decimal form is 1.0, and the lowest number you can get in decimal form is 0.0. Okay. So again, if you need to be consistent of how you write your answers. So if you have in decimal form, you would have it in this form. Now, if you convert it to percent, okay, then you just need to multiply this by 100 or move this decimal 2 places to the right, and that will give us 8.08%. But make sure you put a percent sign there to indicate that you're talking about a percent not just the decimal form. Okay. So that's what I mean about being consistent. Okay. So again, but either the O's are correct. Either you write 0.00808 or 8.08%. Now, of course, you need to be careful what the question is asking. If it's asking like round to four decimal places to the right, then, most likely then you would use the decimal form. Okay. But if you then need to convert to percent, that's fine too. Okay. So anyway, so again, what does that mean? So that means that if you got a z-score of negative 1.4, then the percentage of men that are shorter than 63 inches is going to be 8.08%. Okay, or 0.0808. So that's what this is saying. That's the percentage of men that are going to be shorter than 63 inches. Okay. Okay, so now let's answer the second part of this. It says, what proportion of men is taller than 63 inches? Okay, so that's what I mean. Like, you need to be careful where you shade it, okay, because it depends on the question. If it doesn't say anything, then it's always to the left. You always shade to the left. But in this second part, it's saying we want the proportion or the area that is taller than 63 inches. So that means we want to shade what? To the right. We want this area here. Okay, we want this area here. Okay, because that's taller than 63 inches. Okay, or more than, I would say more than, greater than. Those are some key words it will say. So anyway, so we want this area. We want this area here to the right. Okay, if it's asking taller. Okay, so we know the whole thing is 100%, right? We know the whole thing on the normal distribution curve is 100%. And we already calculated to the left, okay, of negative 1.4. Okay, so that was 808. So all we need to do is just subtract them. 100% minus 808. Okay, all right. So when we do that, we get 91.92%. Or in decimal form, 1.00 minus 0.0808 is equal to 0.9192. And notice I don't put a percent there because I'm not referring to a percent. This is just in decimal form. But anyway, either one of these is correct. Okay, so this part of the lecture is just a continuation of what we've been learning, but we're going to finish it off. Okay, so let's go to the next, again, I'm just going to pick the slides that's going to help us and prepare us for our exam. Okay, let's go to slide number 9. All right. It says, use this table or the Alex calculator to complete the following. Give your answers to 4 decimal places. Okay. Find the area under the standard number curve to the right of z equals 1.41. And then find the area under the standard number curve between z is equal to negative 2.46 and z is equal to negative 1.03. All right, so let's look at the first question here. Okay, so it's asking us to find the area under the standard normal curve to the right of z is equal 1.41. So again, what you want to do first here is you want to label your z-scores, right? So this is 0. You'll always start 0 in the middle for the z-scores. Then you have 1, 2, 3 to the right. And then to the left will be the opposite, -1, -2, and -3. Okay. And we want 1.41. So that's going to be between 1 and 2. So probably halfway, right? Or just a little below half. So this is going to be 1.41. Okay. So normally, so again, let's mark this off. here, right? So normally, what we would do, because the Z table is only displaying the area to the left of that Z-score. So it's only displaying the area here. Okay. So let's go ahead and figure that out. So, all right, so this area here. Okay. So let's go to our Z table and find out 1.4. All right, so here is our Z table, all right, for standard number distribution curves. So we want to look for 1, 4, 1. So here's 1, 4 right here, okay? So we want 1, 4, 1. So we don't want the first column, but the second one. So this one would represent, okay? This will represent 1.40. This will represent 1.41. This will represent 1.42, so on and so forth, right? And all the way up to 1.49. Okay, so if I'm looking at, here, if I'm looking at 1.4 here, okay, all right, so that's how you would read this. Okay. All right, so again, we want 1.41, so that's going to correspond to this number here, right? So this is the area, the percent, I'm sorry, the percentile, proportion, whatever you want to call it, to the left of that Z-score, okay? So 0.9207. So let's go back to our graph here, okay? All right. All right, so this area here to the left, okay, is 0.9207. All right, or we can write it as a percent and write 92.07%. Okay. All right, but is that what it's asking? No. Why? Well, because it says we want to find the area under the curve to the right of Z 1.41. So it wants this area right here. This is what it wants. This information here to the right. Okay. So again, what we can do is we know the whole thing is 100%. So we can just do 100 minus 92.07%. Okay. Which gives us 7.93%. Or we can do 1.0 minus 0.9207, which is 0.0793. Okay. So in this case, it looks like they want to give answers to 4 decimal places. So they want the one with just the decimal. So we would write 0.0793 because that's 4 numbers after the decimal. Okay. Okay, so let's look at the next question then. It says find the area of the standard normal curve between. Okay. So when it says between, what we want to do is we're going to subtract. So remember that. Okay. Between means we subtract. So so first let's find these Z where they're at. Let's mark them on our number distribution curve. So let's make this a little bit bigger. Okay. So this other one was part A. This is part B. Okay, so we want negative 1.03. So again, 0 is in the middle. Here's negative 1, here's negative 2. Okay, and there's 1, 2. So we want negative 1.03. So that's just past negative 1, so about right here. Okay. And the other one we want negative 2.46. So it's about right here. Okay, so here's negative 1.03. This is negative 2.46. Okay, so let's mark these off, and I'll use a different color for these. Okay. All right. So what's going to happen is, we're going to when we find the areas, they're gonna overlap, right? Because this will shade everything to the left, and this will shade everything to the left, right? Or the areas to the left. And what we want is where they're overlapping. Okay, so we want where they're overlapping. So it's gonna be between here. Well, there's a part of it that is overlapping. I shouldn't say this is where they're both overlapping. Okay, so they're only overlapping in this portion right here. But what we want to do is, what they're asking is the area between is where I just marked off, right? This is the area that they want, is in between. Okay. So scratch the part where I said overlapping because the only part that they're overlapping is this area here. Okay. But anyway, the key part here is when we see the word between, we want to subtract. And this is the piece of information that they want. So how do we do that? So again, we're going to have to find the areas for these corresponding z-scores. Okay, so to save us some time, I have already found those. Okay, well, let's just look at it so we can get familiarized with it. All right, so we need to find negative 1.03. So here's negative 1.003 is right here. So that's going to correspond with 0.1515. Okay, and then the other one we're going to find is negative 2.46. Here's negative 2.4, and we want 6. So this is negative 2.46. So that will be 0.0069. Okay, so those are the two areas that we want. Okay, and what we're going to do with those, we're just going to subtract them. Okay, so let's go back here. All right. So again, negative 1.03 corresponds with, let's go back, 0.1515. Okay, so 0.1515 and negative 2.46 corresponds with 0.0069. Okay, and all we're doing is we're subtracting them. Right, so when we do that, we get 0.1446. Okay, or 14.46%. Okay, so that's what this is representing. Okay, so 0.1446 or 14.46%. Okay, I'm on slide 11. All right. It says here Yolanda is a civil engineer working for the city of Indianapolis on a project to widen some of its downtown streets. One aspect that she has to consider is that during the hot summer months, the noonday temperature of the asphalt of these streets can get extremely hot. For the project, she models these temperatures of the asphalt using a normal distribution with the mean of 109 degrees Fahrenheit and a standard deviation of 12 degrees Fahrenheit. Okay. Find the percentage of noonday temperatures of the asphalt between 100 degrees Fahrenheit and 124 degrees Fahrenheit, according to the model. For your intermediate computations, use four or more decimal places. Give your final answer to two decimal places. For example, 98.23%. All right, so let's go through this. Okay, so let's try to decipher the information that they gave us here. Okay, so um, it says here that for the project, she models these temperatures of the asphalt using a number distribution mean of 109 degrees Fahrenheit and standard deviation of 12 degrees Fahrenheit. Okay, and we want to find the percentage, okay, of the temperatures of the asphalt between. So that's the keyword. 100 degrees Fahrenheit and 124 degrees Fahrenheit. Okay, so we need to calculate first our z-scores. Okay, so we'll have, again, we're going to use a formula. Z is equal to x minus mu over sigma. Okay, so the first one, use a different color here. Okay, we have Z is equal to um, 100 degrees Fahrenheit. Okay, so we have 100 degrees minus mu, which is the average, 109, divided by the standard deviation, which is 12. Okay, so when we put that in the calculator, we get negative 0.75. Okay, so now we need to calculate the other component. So Z, so the other one's going to be 124. So 124 minus 109 divided by 12. Okay. And that's going to give us 1.25. Okay. All right. So now what we need to do is we need to find those areas, right? So negative 0.75, just to save us on time, I already found that out. So the area of that is, again, I just looked at my Z table chart. That was 0.2266 or 22.66%. Okay. This is 0.75. The other one is the area of this one, when I look at the chart for 1.25, is 0.8944 or 89.44%. Okay. Okay. So let's go ahead and mark those off on our chart here. All right. So again, there's 0, 1, 2, 3, -1, -2, -3. Okay. So what we want is the area between. So negative 0.75 is closer to 1. So here it is. Okay. And 1.25 is right here. Okay. All right, so let's mark those. So 1.25 is right here. The other one's right there. Okay. So what we want, again, they're both being shaded to the left, and what we want is the area between them. So we're going to, again, subtract. Okay. Between means to subtract. So we want this information right here. Okay. All right, so all we have to do now is subtract our percentages. Okay. So we're just going to take 89.44, okay, minus the 22.66. Now, why am I picking the percentage? Because it says it wants the percent. So that's what I'm doing, the percentage one. Okay. So when we do that, we get 66.78%. Okay. And that's our final answer.